Hey guys, I'm making this video just to try to help you understand and get started on the practice set. So I'm going to just do a little bit of each one and then, just to help you get started. Okay, so we are starting here on this these graphs, which this is asking you to match each graph with its derivative, right? And so for this one, you have to remember the idea of what a derivative is, right? And the derivative is the slope of the original function, right? So when I'm looking at this original function, I'm asking, well, what's the slope at a bunch of different points, right? So if I look at this first one, which is that line, I should know that the slope of a line is constant. And in this case, the slope is a positive number. So when I look at the derivative, I'm looking for something that is a constant function in the positive side, which is above the x-axis. And so I would be looking at either b or f because both of those are constants. But then f has this weird hole, and that would tell me that it should not be f because there's no reason for there to be a hole. There's no point that it's not differentiable on this line here. So for this first one, it's b, right? And I'll do one more with you. The second one is over here. As I go on this, all my slopes are positive, right? These slopes are all positive slopes. Right? Meaning my derivative should be above the x-axis. Right here, this is zero slope. And then after that, these are all negative slopes. So I'm looking for a graph that starts above the x-axis, right? And then is on the x-axis at x equals 0, and after that is below the x-axis. So if I look at A starts below the x-axis, so already that's off, right? So it can't be A. If I look at C, it's always above the x-axis, so it can't be that one because at some point I need after 0 it should be below the x-axis. If I look at D, it starts positive, right? At 0 it is 0, and then after 0 it's negative. So D totally works, and D is the correct one, right? Another way to look at that is, well, this parabola, this is a parabola that's upside down. If I take the derivative of parabola, which is x squared, the derivative of that's going to give me a line. So I'm looking for a line because it's upside down parabola. It was negative, which gives me a negative slope line, so a line that's going downwards, right? So those are those first two on that one. Okay, the next one is over here, and I'm just going to do the R one for you. It says R of x equals f of g of x. Find r prime of 1. So before I can find r prime of 1, I need to find r prime. And because I have a composition of functions, right, f of g of x, I need to use the chain rule. So this is going to be f prime, the inside stays the same, times g prime of x, right, times the derivative of the inside. And I want to find r prime of 1, which means I need, everywhere I see an x, I need to plug in 1, right? So let's start here, f prime of g of 1. So let's start with, what is g of 1? That's not a very good color. Let's maybe use yellow. What is g of 1? So I go over to my graph and I look at, okay, here's 1. G of 1 is 1, 2, 3, 4, right? So this value here is 4. So I have, next I'm trying to find f prime of 4 times, that was supposed to be 1, 2, g prime of 1. Now I have to remember what g prime is, right? G prime is the derivative, which, what does the derivative tell us? The derivative tells us the slope. So I'm asking, well, what's the slope of g at x equals 1? So I'm going to 1 again, right? But instead of looking for the y value, I'm looking for the slope here. What is the slope here, right? Well, this is just a horizontal line. The slope of a horizontal line is 0, right? So that is 0. And I could stop at this point because anything times 0 will be 0, but just for the sake of getting used to this, let's go and find what f prime of 4 is, right? F prime of 4 says what's the slope of f at 4. So I'm going to go to 4, 1, 2, 3, 4, and I'm looking here. What's the slope here? Well, it's a line, so the slope is the same everywhere. What is the slope? Well, it's rise, 4, run, 3. So that slope would be positive 4 over 3. Right? F prime of 4 is positive 4 over 3 because it's the slope of the function. at that point. All right, so again, I'm still just going to get 0 on this because I'm multiplying by 0, but let's just write it down here. F prime of 4 was 4/3, but then I multiply it by 0. Okay, so that's that. Move on to the next one, which is here, y equals u times v over z. We're going to need to use the quotient rule and the product rule, and the issue is that in the quotient rule and product rule we've been using u and v, which there's already a u and v here, so it could get really confusing. So let's do the product rule in terms of f and g, the quotient rule in terms of f and g, right? If I have f over g and I take the derivative of that, I will get f prime g minus g prime f all over g squared. And this might help us do this one, right? Where this whole thing is f and the bottom is g. So first thing I need to find is f prime. Well, while finding f prime, I have to find the derivative of the top, which is a product. So I have to use the product rule on that. Product rule is u prime v plus v prime u. So that's the derivative of the top. This is, or the way we did it, this is f prime. And I have to multiply that, the entire that, by the bottom, which is just z. Right, so that's g. And then I have to subtract g prime, which is simply just z prime, times f, which is the derivative of the top. The derivative of the top, or sorry, just the top, is u times v, and the whole thing is over z squared. Right, and so that is basically what it is. Let me just write a couple things in here. This z prime was, this is if we're doing our derivative thing over here, this was g prime, and this guy was just simply f, right, if we're using this formula over here with the f and the g. Okay, so that's that one. Let's keep going. Down here we can do one of these examples. Let's see, let's do this table value one first. This one's telling me if h of x equals f of g of x, write an expression for h prime and use it to find h prime of 2. So again, h prime, because we have a composition of functions, is going to be f prime of g of x times the derivative of the inside is g prime of x. Okay, that's the first part. That's an expression for h prime of x. Use it to find h prime of 2. That means I need to plug in 2 everywhere, right? And then just find each of these pieces individually. So let's start here on the inside, g of 2, where g of 2 is 5. So this thing's going to turn into h prime of 2 equals f prime of 5, right? This guy was just 5. And then I need to find g prime of 2. So g prime of 2 is the square root of 2. So this is the square root of 2 there. And now all I'm left with is, well, what is f prime of 5? F prime is here. 5 is pi. And so we will get pi times root 2. And well, what is that? That's h prime of 2 is pi times root 2. That's how that goes. Right? When you look down here, please notice that this is a product. Therefore, you need to be using product rule. Please notice here that this is a quotient. Therefore, you need to be using quotient rule. Right? You can't just take the derivative of the top and the derivative of the bottom and you call it good, right? You have to do quotient rule to find those derivatives. Okay, let's go on to the next one. For each of the following, find the equation of the tangent line to the given function at the indicated point. When I'm thinking of tangent lines, I know it's a line. I like to think of this. Not that, because that's wrong. I like to think of this: y minus y1 equals mx minus x1. This is the equation of the line, tangent line, where I need this information, right? So the information I need is I need x1, y1, which that's given to me, right? That is x1, y1. And then I need a slope, which to find the slope of the function, this is simply going to be f prime of x1. So what do I need to do? I need to take the derivative, plug in 1, or plug in my x1, which in this case is 1, and that will tell me the slope. And once I know my slope, I can just put it right there on there, right? So Well, I have to take the derivative of this guy. There's several ways you can do it. Either you can recognize that this is a product, right, u times v, or, you know, maybe it's easier to actually just multiply these things and then take the derivative, right, because this is something you could just multiply, right? And the same thing is true about b over here. Is it's the same process, same idea, but there's a quotient going on here. There's no way to get around using quotient rule on this. So this one you have to use quotient rule to find f prime of -2, right? Because that's where we want to know the derivative is at -2. And that'll give me the slope. And again, I'll just plug in my slope into the point slope form along with that point, and I'll have my equation of the tangent line. All right, let's keep going. Actually, I'm going to stop there because this one's a little bit long, and I'll make another one that will do the back side of the pages. All right, so look for the other one to do the rest.